For generations, our world has challenged explorers to seek what lies beyond the horizon. Now, the invention of spaceflight is leading us outward to explore a host of alien worlds with vast new territories. Today, we see the sun, moon, and planets with penetrating clarity through the eyes of the intrepid machines blazing a trail for us across the solar system. Their cameras have become our windows onto a bold new adventure. Their discoveries have become our cosmic vistas. To the human eye, our universe is all about light. It's the sign that matter is present in stars, in galaxies, and in great expanses of glowing gas. But despite its beauty, this colorful realm of gas and stars is not a place where life can exist. Life as we know it is too fragile to survive the searing temperatures that make atoms of gas glow in space. What life needs is a very different kind of place. One not simply made of swirls of gas, but of something solid. Life needs a rocky planet. Without planets made of rock, there would be no chance for life as we know it. But simply having a solid place to stand is no guarantee that life will gain a foothold. We can see this in our own solar system, where there are many different kinds of rocky worlds. First in line is Mercury, a small and mysterious planet that is alternately baked then frozen as it slowly rotates in the sun's glare. As the nearest planet to the sun, Mercury's daytime surface temperature can reach more than 420 degrees Celsius. Yet on the planet's night side, where heat is quickly radiated into space during long months of darkness, the temperature can drop below -180. For decades, Mercury's one and only visitor was the Mariner 10 spacecraft, which flew past the planet 3 times, starting in 1974. It gave us our first close-up look at Mercury's baked and battered surface. But Mariner 10's view was incomplete, capturing less than half of the planet during its few brief encounters. So, in 2004, NASA launched a new mission, Mercury Messenger, whose goal is to orbit Mercury and provide the first comprehensive survey of its geological features and mineral composition. At first glance, Messenger's images seem to be showing us a desolate and moon-like world. The surface is rough and heavily pockmarked with craters from billions of years' worth of meteorite impacts. But first impressions can be deceiving. Although Mercury is only slightly larger than our own moon, its gravity is more than twice as strong, which means Mercury is much more massive. In fact, Mercury is so heavy, it may be almost entirely made of metal. Some scientists have speculated Mercury began its existence as a much larger planet whose exterior was mostly shattered away in a giant collision, leaving behind only a thin rocky mantle surrounding a large metallic core. Whatever happened, it's clear Mercury once bubbled and rumbled with the internal heat from a tumultuous formation. Numerous features suggest a world that was volcanically active in the distant past. This view shows a landscape with multiple ripples underlying the more recent impact craters. The ripples, frozen in time, reveal where vast pools of lava once flooded the planet's surface. In this image, false colors help to highlight Mercury's complex history. Here, the bluish areas represent an ancient terrain that was gradually buried by debris, shown in orangey red. The debris is made of material kicked up by large crater-forming impacts blasted into Mercury's surface. There are also giant cliffs and escarpments threading their way among the craters. These cliffs are a common feature on Mercury. They may have formed when the planet's giant metal core cooled and contracted, causing the overlying rock to wrinkle like a planet-wide version of shrink wrap. Messenger's first views of Mercury reveal the bare bones of a rocky world. There is nothing here but a solid surface that hasn't changed very much over eons of geologic time. While Mercury may provide the beginnings of a stable platform, it is far too hot and barren to be anything other than an empty stage. To transform a dead planet into a living world, more ingredients are needed. First and foremost, an atmosphere. Lack of atmosphere is not a problem for this planet. Enigmatic Venus is the second rocky world from the Sun. Permanently shrouded under a dense, cloudy atmosphere, Venus was hidden from astronomers for centuries, despite being the nearest planet to Earth. Now we know that Venus's atmosphere is a toxic brew composed of carbon dioxide with clouds rich in sulfuric acid. The carbon dioxide is brutally effective at trapping the sun's energy, heating up the planet to a staggering 460 degrees Celsius. That's even hotter than Mercury, although Venus is twice as far from the sun. And Venus's atmosphere is incredibly dense. The air pressure at the planet's surface is so high, it would easily crush a human astronaut to death. These conditions are so extreme that to date, we have only fleeting glimpses of Venus's surface taken by a handful of Soviet landers, none of which survived more than 2 hours. With a planet so inhospitable to spacecraft, scientists have had to come up with another way of exploring Venus's hidden terrain from a safer distance. Radar can penetrate the planet's thick blanket of clouds and bounce off the rock below, providing a detailed look at a bizarre and dramatic landscape. What these images reveal is a world shaped by volcanoes, and one that could still be volcanically active today. The apparent lack of impact craters, so different from what we see on Mercury, is a strong indication that Venus's surface is young and may be continually evolving. Scientists now suspect that in the past, Venus may have been much more like our own planet. But as its atmosphere heated up, it lost something vital that makes Earth special in our solar system. It's water. Here on Earth, oceans have played a key role in keeping our planet suitable for life. Not only do oceans moderate the climate and help keep the atmosphere stable, they lubricate Earth's rocky surface, so its internal heat is mainly channeled into moving the continents slowly around the planet. Without water, heat would build up and burst out in vast and deadly lava flows, as may have occurred on Venus. Most of all, oceans provide a liquid medium where complex molecules can interact. The preconditions scientists now believe are necessary to turn mere chemistry into biology. Earth is our best example of the true potential of rocky worlds. It seems that when a planet has all three ingredients, a solid surface, an atmosphere, and oceans of liquid water, it can foster something new, the emergence and evolution of life. But while life has come to dominate Earth with its richness and complexity, it has also buried its tracks, making it difficult to understand how our planet came to be the way it is today. That is one big reason why scientists are so keen to explore the rest of the solar system, now that the technology is available to do so. It is here where we may find the clues that will tell us what Earth was like before life appeared, and how it all happened. It may be that only when we reach across the ocean of space to distant rocky shores can we truly understand our own identity. In all of nature, there is perhaps no view as haunting and beautiful as a full moon. It is both familiar and mysterious. A part of our world, yet a world unto itself. Today, we look across at our nearest neighbor and find not a mirror image, but an alter ego. While Earth looks lush and colorful, the moon is a study in black and white. While Earth's surface is shaped by water and air and abounds with the sounds of life, the moon's is silent and still. Here, no rivers run, and no winds blow. All that exists are memories of events long past, memories of our solar system's violent beginnings and Earth's own tumultuous history. For billions of years, the moon has been the ultimate silent partner, keeping watch over Earth from above and keeping its secrets to itself. That's not very satisfying to humans, which explains why every civilization in history has its own myth about how the moon came to exist. But only after the invention of spaceflight did we finally get the real story.
30 seconds forward. 30 feet down, 2.5. Picking up some dust. Contact light. Okay, engine stop.
To date, over 50 spacecraft have now flown past, orbited, or landed on the moon with eye-opening results. At long last, our silent partner is beginning to reveal its fascinating story. When viewed up close, the moon's surface is inundated with impact craters. They form when small asteroids collide with the lunar surface at high speed. The energy from a large impact is enough to liquefy and hollow out a crater many times the size of the original impactor, while throwing debris thousands of kilometers in all directions. Over billions of years, our planet has experienced just as severe a beating. But on Earth, impact craters are eroded away or buried in sediment over time. On the moon, they simply accumulate, leaving a vivid and detailed record of the hazardous nature of our solar system. By carefully counting craters, it's possible to tell which parts of the moon's surface formed first and which came later. For example, the dark patches on the moon we can see even from Earth are clearly younger than the surrounding bright areas. In the past, astronomers named these dark patches Maria, Latin for seas. But when explored up close, it's clear there's never been any water on these alien shores. Rather, the Maria are vast, low-lying plains of volcanic rock. Long ago, these plains were covered in hot lava that spilled out from the moon's interior and flooded over an older landscape. Because they are richer in iron than other parts of the moon, they appear darker in contrast. One of the big achievements of lunar exploration has been the complete mapping of both sides of the moon's surface. The moon rotates in perfect time with its orbital period, with one side constantly facing Earth. Surprisingly, the two sides of the moon turn out to be quite different from one another. While the side that faces Earth is covered with Maria, the moon's far side exhibits much less contrast. It's an ancient, rugged terrain interrupted only by a few larger impact sites. This peculiar two-sidedness has to do with the moon's crust, which is substantially thicker on the far side. Scientists now suspect that billions of years ago, when the moon's internal heat forced lava upward, it found a shorter route to the surface on the moon's near side. But how and when did those circular plains form in the first place? The surprising answer comes from the lunar samples that were brought back by Apollo astronauts. The samples show the lunar Maria were once the sites of enormous impacts, many of which date back roughly 3.9 billion years. This is very early in the solar system's history, when space was more crowded with debris than it is today. Nevertheless, the evidence now suggests something exceptional happened 3.9 billion years ago, as though a storm of asteroids suddenly swept through the inner solar system, pummeling all of the planets as well as our own moon. The devastating barrage left the moon plastered with giant circular scars. On Earth, it was much worse. The impacts would have vaporized oceans and liquefied large sections of our planet's crust. Though no animal or plant was living on Earth at the time, it is possible microbial life had already made its debut. When the bombardment came, perhaps only those microbes that were dwelling far down near deep sea vents survived to repopulate the ancient Earth and become our distant ancestors. The idea that the moon and Earth were both heavily bombarded is one of the big results to come out of the samples that astronauts returned to Earth. An even bigger one is the astonishing revelation that the moon itself may have once been the product of a giant collision. This theory is that early in our solar system's history, an object as large as Mars once collided with Earth and dealt our planet a staggering blow. The collision immediately spewed out vast amounts of debris. Much of this material found itself in orbit around Earth, where it eventually coalesced to form a single large moon. As incredible as it seems, this giant impact scenario offers the best explanation for some of the moon's more puzzling features, including its apparent lack of an iron core. Ironically, the moon's destructive birth may have also been crucial to maintaining Earth as a cradle of life, unique in our solar system. The moon's presence helps to stabilize the tilt of Earth's axis, preventing climate swings that would be devastating to life and civilization. Because of the way it formed, the moon's past is intimately linked with our own. Without it, the evolution of life may have taken a very different course. In fact, if it weren't for the moon, we might not even be here at all.
Houston, Tranquility Base here. The Eagle has landed. That's one small step for man, one giant leap for mankind.
Exploring the moon has given us a remarkable window into the past. But the moon may also be our gateway to a long-term future in space. In the US, China, and elsewhere, efforts are now underway to return humans to the lunar surface. It is an ambitious goal, but it's also a stepping stone along the road to more distant destinations. Exactly where the next human mission will land is still an open question. But one thing is certain: there is no shortage of interesting places on the moon where scientists would love to visit. The lunar South Pole would surely be at the top of their wish list. Here, the sun never shines on the floors of some craters. Forever in shadow, these dark craters should be cold enough to trap water vapor and maybe even form lunar ice. Although the moon is dry, the water vapor could come from comets colliding with its surface. Scientists have now confirmed the presence of hydrogen in many south polar craters, strong evidence for the presence of ice. If there is enough ice, it could provide lunar explorers with much-needed water. But finding and retrieving the ice will be a challenging task, as it would involve venturing into perpetually dark places. Today, the moon presents us with an intriguing and exciting destination in space, and a staging ground for even more daring explorations on Mars and beyond. Perhaps more than any other location in the solar system, it is the moon that tells us we live on just one world among many. And if we are determined enough, we can one day visit them all.